Professor?
Exam? No, I made that. Can I get a copy of the applications, the derivative summary? Did he give you one?
No, I didn't get one.
She has it.
Is it from?
I'll give you one.
Yeah, she has it.
I got extras. Amber, that's a summary of like 4.1 to 4.3. That whole sheet.
I squeezed it in one sheet. A summary of 4.1 to 4.3. Got it all in one sheet. That was my goal.
Professor,
That handwrite stuff. Oh, go ahead, Art.
can I go, actually, she and I were having a discussion, 4.2 number 7, the graph. I
Yeah, let's
mean,
do it.
yeah, I mean, it's kind of.
Mean value theorem?
No, I mean, we got it at 3.8, but we couldn't find the C. I mean, like, it's very confusing. I know there was, C has to the same kind of, what you say.
Oh, number 7? Yeah. 7 is where it's like they just gave this sketch, and we gotta, the only way we can do that problem is we use this really sharp pencil. What's the slope between the endpoints?
3.8.
So the slope is 3/8.
Mhm.
So then every time we're trying to estimate all the points where that really happens,
It's 3 tangents.
yeah, you'll draw that one tangent line, right?
Mhm.
And then we're just gonna use a sharp pencil to try to find where that slope would be just parallel.
Here's the one.
If you
no,
can
there's
tell, it's almost like we can just,
one.
we're really just estimating. So I didn't want you to get upset if you look in the back of the book and you're like, you said 1.2 and the back of the book said it actually go to 1.3. Because there's that puny sketch right there. And that means that even the thickness of the pencil lead, Art, do you agree? You
Yeah.
can throw it off a decimal point or two. So don't let that problem bug you. I signed it though, I love the concept that you can look at something and go, all right, how many times does it happen to discuss the mean value theorem? But that's it, like most important for me for that problem is just to recognize it happened 3 times, there's 3 C values, we can estimate where they are, but you don't have to hit it perfectly to like 1 decimal place or something.
We got,
That's all good, so where was the first one at? At x equal to what?
1, 2, 3, 4, 5, 6. One is x equal to 6.
All right.
One is at 1, and 2, 3, x equals to 3. Another one is at x equals to half, or,
Yeah, one was early, around half or so, like right at the beginning.
Mhm.
It had that little dip. That's good. I mean, just somewhere approximate of where the x values are. Do not think that you gotta be able to look at that sketch.
yeah, there's no way.
There's no way. There's gotta be more details. Maybe it should be larger, so you can actually take, because all we're doing, we're taking our pencil lead and we're going, all right, straight lines. Because they didn't give us the equation of the curve.
Yeah,
That's it. That's what's good.
If you're gonna do any like review problem, could you do like a hyperbolic function problem?
Yeah. You want the hyperbolic function, let's see, keep in mind, the derivative of hyperbolic sine is just
cosine.
hyperbolic cosine. We put this h after the s, right?
Mhm.
Feel free to call it cosh. I don't know what you'd call that though, sine hx, so I'd call that hyperbolic sine, but I call this cosh of x. Well, the derivative of sine hx, hyperbolic sine is cosine of x, cosh of x. And then the derivative of cosh is what?
Sine hx.
But not like SCSES where you and I did this. With trig functions, yikes. SCS. We did trig functions like that, remember this? Then we're saying with hyperbolic functions, it does that, doesn't it? It just keeps always positive.
What kind of question would you specifically ask?
With that one, it would be a chain rule problem, similar to the ones we did in class, to recall. Like I remember we did one problem, if you recall this, I can make up a function, but just so you can, I wanna make sure you understand chain rule. Where we, there was a catenary,
Yeah.
remember that, between the two poles? And we had to find the slope at the right pole. It was like x equals 7. There was an equation given, but you and I knew, okay, we're just gonna take the slope and plug in a 7,
Yeah.
right? But, I mean, I'll make something up. It's just like, if you're given some function, let's say y equaled 40 sine h of x over 40 plus 22 minus 19. I'm just making this thing up, right? But here you got some hyperbolic function here with the hyperbolic sign. Let's find the derivative though. So differentiate. The 40 stays with the constant, right?
Mm-hmm.
All right, what's that become?
Gosh.
Gosh, good, you're doing chain rule. I like this. When we do chain rule, that's G. We put all G back in. All right, so let me put all G back in. Here's G. And then multiply G prime.
That should be
The
one.
derivative of where we call this part what? We call that G. Now be careful, it's not too bad. What's the derivative of a 1/40th x plus 22? The plus 22, to differentiate that, you get 0, right?
So
But a 1/40th x,
1/40th.
you just get 1/40th, don't you?
Mm-hmm.
Okay, good. So let's multiply 1/40th. Now what happened to this derivative? That just
Zero.
became what? 0. I'm going to multiply now the derivative of what? 1/40. Cool. And I just made this up. And now you go, okay. And if you want, see this 1/40th at the end? And with the beginning of this 40, we could what? They cancel. Let me write it again. X over 40 plus 22. Now, so that's, you differentiate it, great, that's what was key, I wanna make sure you can do that. And then second thing we did, I remember with the application problem, we had to find the slope at the right pole, it was like x equal to 7, so could you evaluate this slope at, I'm just gonna make up a value, x equal to 5. Okay, we just have to plug in a what? 5, but do you know how to do it on your calculator?
No, I don't.
Cool, I wanna show you where the cost is. A lot of us go to the catalog. So I say that, I'll show you what catalog is, it's nice. That way you don't have to put in the original hyperbolic function. Okay, you got the calculator working? Boom, yeah. Second, 0, catalog. Let's get to the C's though. Where's the C, right there? All right, boom. And we're looking for Coshex. Yep. But see, the key is, you don't even have to worry about the C. The key was, you want to get the catalog, which gives you the menu, the whole calculator. In this menu, it has to have the hyperbolic function somewhere. I just didn't feel like scrolling forever, so I was like, how can I get to the C's quickly? So I saw C right there, and I was like, thank you. I still gotta go down to what? Gosh. Oh, for hyperbolic sign, look, right there. Keep going, there it is. All right, now we gotta type in what? I said it 5 by 40, and then plus 22, and you can evaluate. Does that work? Holy cow, that's huge. That's crazy. Cool. It's funny, we didn't go so heavy on that section. It's just, we're gonna know these. You may see these from time to time. Calc 2 course, there might be a little problem where all of a sudden a hyperbolic function comes up. They didn't allot a lot of time actually in our syllabus for it. They just want to make sure everyone hit on those. I'm like, okay, I get you. Make sure the students are aware of these, but don't go crazy with the inverse hyperbolic functions and stuff like that. If anybody saw that in the textbooks, you have to do those.
What about the formula? There's a formula for these, the y equals EX.
I think it's great to know those. You don't have to memorize them. I think it's great to be aware of that. Because a lot of students don't know that. They think these are like trig functions. They get in the calculator, it's like this, there's something going on where happens to a lot of students, they go, "Oh, those the trig functions," or like, they're not even a part of, their relationship is just like trig functions, but they're not. Those are the actual functions, the e to the x plus the e to the negative x all over 2. It's good to know it, you don't have to memorize it. It's good to know that, so you're aware that this thing, this function right here came from another function. This right here. And it's e to the x. Is this the one with the plus or the minus? I don't even know.
Minus,
This is the one with the minus. So it's e to the x minus e to the
negative,
x all over 2. And then the cosh has a what in the middle?
plus.
Plus. So it's good to know, you don't have to memorize them, it's good to know that. You know? I'll tell you what, online students, sometimes they don't know the cosh and the hyperbolic sign are in that catalog, so they're typing things like this when they gotta evaluate like x equals 5 and stuff. They're plugging 5 into that. Cool. Alright, hey, any other, these are great questions. Anything else? Alright, hey, the last thing we left. I'll make sure at the end of class there'll be time if you have any questions. The last thing we left off on was this, it was an abstract topic. We had to actually look at a derivative graph, Amber. And this is what we did last class at the very end. And then we had to kind of think about what's going on with the original function. So that's abstract. There's not going to be any equation given to you. We're just going to go by the definition. So if you're like, I'm not aware of some of these, they're all on a sheet. These definitions for like, what does concave up mean? What does concave down mean? What's it mean for a function to be increasing or decreasing? It's all on here. So, you want to build another one?
Yeah.
All right, so and we're just going to build something. We'll build some derivative graph, and then we'll answer a bunch of questions about what's going on with that. Cool. All right. These are fun, but they're not so much fun if you're not seeing it. So just ask me questions if you can. It is kind of abstract just because you're not getting a function given to you. And you just got to go by the definitions. All right. So this is in 4.3. All right, here's an F prime graph. I always have a habit of writing the same exact thing I did the last time. I gotta make sure I didn't do it. So I'm gonna look, anybody has the picture of the last graph I did? I'm gonna change it up at that. Oh, thank you. All right, let's switch this thing up. I went down like that. Let's go down then. Let's pull this thing up somehow. Maybe that. Now I'm gonna make up some x values, okay? That right there is x equal to -7. Right here, when this thing bottoms out, remember that's x equal to -4. Right there, that x-intercept, that's x equal to -2. And when this thing gets to the highest point right there, that's x equal to 1. This isn't drawing a scale, I'm just making up some x values. Right here, this is x equal to 5. Right there, that's x equal to 8. And then right over here, this is x equal to 11. On a test, when Professor Mestre builds a graph like this with software, if you can't tell where it got to its highest point, if you think it's like 1.2, I'm okay if you know. I mean, I'll generate it with software if you like that. Looks like it's at 1.2. But I try to make them nice integers so you can answer these questions, okay? All right. Now this is in 4.2. Now where are the problems in the book that are kind of like this? You would see it right at the beginning. So at the first few questions, Stewart's textbook does that. He kind of hits on these concepts, right? Leave these out here in case someone wants an extra. Sometimes they have a student in another class and they give it to them. So we'll go through this.